Hi all, today I'll be doing Chemistry 10 Practice Problem Lecture 13. It's about properties of gas and unit. Number 1. List of properties of a gas and their SI unit. So properties of gas and their units are pressure, or P, and the example is ATM or atmosphere, torr, and mmHg or millimeter mercury. And second one is volume, which is V, and the unit is in liter. The third one, amount, or N, in mole. And the fourth one, the last one, is temperature, or T. It's in Kelvin. Number 2. On a climb up Mount Whitney, the atmospheric pressure drops to 467 millimeter mercury. What is the pressure in terms of ATM and torr? So for torr, it's just the same amount because 467 millimeter mercury is 467 torr. So millimeter mercury and torr is the same unit. 467 millimeter mercury in atmosphere, I count it as 1 atmosphere per is 760 millimeter mercury. So this one cancels out, and I got 0.614 atmosphere. Move on to number 3. Understanding the conditions for using Boyle's law. What two properties of a gas are considered in Boyle's law? So two properties are P and V, which is pressure and volume. And state in one sentence how these two properties are related to one another. They are inversely related. What properties of a gas must be constant for us to use Boyle's law? The constant one are amount of mole and temperature, T. Write the formula for Boyle's law. So Boyle's law is P1 V1 equals to P2 V2. And again, this is inversely related. Moving to number 4. Conception understanding of Boyle's law. Why does a sealed bag of chips expand when you take it to a higher altitude? Incomplete sentences, explain this using your knowledge of kinetic molecular theory. So in kinetic molecular theory, or KMT, kinetic energy increase as temperature increase. So here, as the bag increase in elevation, the pressure of the surrounding decrease, meaning that less molecules are colliding with the wall. Same force on the outside of the wall of the bag will increase, in volume. So to decrease the collision rate of the molecule on the inside, therefore the pressure will decrease. And number 5, the pressure of 5 liters of gas increases from 150 atm to 1240 millimeter mercury. What is the final volume in liter of the gas, assuming constant temperature? Here we must first convert the 1240 millimeter mercury into atm. So we will get the same unit as the P1. So this one 240 millimeter mercury times 180 ampere, 760 millimeter mercury, cancel out, and we got 1.6336 atm. So here, this is the P1. Let me write it down here. P1 5.0 liter. And let me see. P1 is 1.50 atm, and V1 is 5.0 liter, and V2 is 1.63 atm. So P1 V1 equals to P2 V2. And they ask the final volume, which is V2. V2 is P1 V1 over P2. 1.50 atmosphere times 5.0 liter divided by 1.63 atmosphere. Cancels out atmosphere. I got 4.6. This is liter. So 2 sig fig. Here liter, 4.6 liter. See here. So this is the answer, 4.6 liter. Moving on to number 6, understanding the conditions for using Charles' law. What two properties of a gas are considered in Charles' law? State in a complete sentence how these two properties are related to one another. So the two properties are T, temperature, and V, volume, and they are directly related. What property of a gas must be constant for us to use Charles' law to predict the behavior of a gas? The constant one will be N and P, amount of mole and pressure. Write the formula for Charles' law. It's T1 over V1 equals to T2 over V2. Again, this is the opposite of Boyle's law. For Charles' law, the relation is directly related. And going to number 7, conception, understanding of Charles' law. A balloon is inflated inside a warm house in Michigan in the middle of the freezing winter. Once you take the balloon outside and leave it there for a while, it shrinks. In complete sentences, explain this using your knowledge of kinetic molecular theory or KMT. So, as the temperature decreases, the molecules have less energy to move and bouncing off the wall. And bouncing less off the wall. And pressure, to keep the pressure constant, volume must be decreased, so the same force will be applied to the wall of the balloon. So number 8, a fixed amount of gas at 25 degrees Celsius occupies a volume of 10 liter. When the pressure is 629 torr, calculate the volume the gas will occupy when the temperature is increased to 121 degrees Celsius while maintaining the pressure. So the pressure will be the same, 6029 torr. So we can ignore this. Here, in this problem, the T1 will be 25, temperature 1 will be 25 degrees Celsius, and then V1, 10 liter, T2, 121 Celsius, and it asks for volume 2. Because the temperature in Celsius, we have to change the unit into Kelvin. So the formula, how to find Kelvin, we have to add 273 here, 25 plus 273, I get 298 degree Kelvin, and here (394 degree Kelvin, 42). So how to get the V2? This is V1 T1, T1 V1 equals to T2 V2. Now we want to find for V2, which is V1 T2 divided by T1. So V1 is 10 liter multiplied by 394 Kelvin over 298 Kelvin. Cancel this out. I got 13.2 liter. So this is the answer. Now we will work on an example where you have to decide whether to use Boyle's or Charles' law to solve the gas problem. Number 9. The air in a 5-liter tank has a pressure of 800 torr. What is the final pressure in atmosphere when the air is placed in a tank that has a volume of 750 milli? If there are no changes in the other properties of the gas, state the gas law used to solve this problem. So here we know the information. This is V1, and then this is P1, and then the second volume V2. So let me write it down here so it will be more clear. V1 5 liter, P1 800 torr, and V2 700 milli. Here we have to change the unit into liter, which is times 1 divided by 1000. So 0.750 liter, the V2. So if we know volume and pressure, the law that we will use is Boyle's law, which is P1 V1 equals to P2 V2. And then it asks for the P2. Here P2 is P1 V1 over, P1 V1 over V2. Torr multiplied by 5 liter divided by 0.750 liter, cancel out. So I got 5,333.33. Let me see, it's a whole number here. So the answer is 5,000 torr. And the one that we use here is a Boyle's law, okay? So today, I went through the properties of gas and unit, which is using Boyle's law and also Charles' law. And I hope you can benefit from this video. Thank you.